the same question with different rule. You'll be told, use trapezoidal rule with 8 steps to evaluate the integral from 0 to pi 2d theta over cube root of 5 plus 4 over 3 sine cubed theta. Are we together? So the first thing, you need to know the function, isn't it? And before you need to know the function, you need to know how many decimal places have you been told. If you've not been told, it is always ideological to work with 4 decimal places. It's realistic, isn't it? But many cases they will tell you maybe 6 decimal places, 5 decimal places, meaning the first step is to fix the calculator into the number of decimal places given, or the ones you want to use. Are we together? So in our case, because we've not been told the number of decimal places to fix, we can use 4 decimal places ideal, isn't it? So fix 4 decimal places. Just go to fix, then the calculator tells you to choose between 0 to 9, you choose 4 decimal places. Are we there? When you're using the right calculator for this mathematics, you shift, then you go to setup. Then you get to the mode, isn't it? Have you done that? You've not done that because you don't have a calculator. So you see you're doing disservice to yourself. Have you now fixed the number of decimal places? Everyone has done that? Yes. You will get where it is later, okay? Good. Then the next, after fixing the number of decimal places, the next thing you need to know is what? The calculator, we are dealing with the limit here, 0 to pi. There's a trigonometry function there, and 0 to pi means the calculator must be pi radians. We are moving stepwise, are you seeing that? Yes. So when your calculator is in D for degrees, you have to change it in R for radians. Because pi is pi radians, the calculator must be in R. So if your calculator is displaying D, you'll be getting wrong things. Are we together? Yes. Your calculator must display R, because from 0 to pi, when trigonometric function is involved, we are dealing with the pi radians. Calculator must be in R. Have you set calculator to R? Have you done that? You set the calculator to R. So we've now started with the default. The default is that the limits here, calculator must be in R, and the number of decimal places must be fixed before we start going with the question. Okay? After you've done that, you now identify the function you want to integrate, isn't it? You identify the function, meaning if you remove this d theta, what is remaining there is the function. Are we together? What is remaining there is the function if you remove the d theta. Because if you are getting the area, you are integrating f of x dx. So if this is d theta, where this x, if you put theta, meaning our function f of theta is the whole of that minus that d theta. Are you seeing? So there, if you remove the theta, what is your function y? Your function y is what? If you block this d theta, in the numerator you remain with the 2 over cube root of 5 plus 4 over 3 sine cubed theta. Are we together? That is the first step. We've not even gone to the rule we want to use. We are still digesting the question, isn't it? We found the function, the y, isn't it? After that, you know the calculator will not give you sine cubed theta, so that cube must go outside, isn't it? So, how is the calculator going to write that? The calculator is going to write it as y is 2 over cube root can be found in the calculator, isn't it? Yes. Then you have 5 plus 4 over 3, then you put the opening bracket for sine, isn't it? You put the bracket, then sine, then calculator will bring for you the bracket for the value which is inside sine, isn't it? Then theta. This is what the calculator will bring, meaning you must put, because sine cubed theta is the short form of sine theta which has been cubed. See, this is the short form of sine theta which has been cubed. Meaning you cannot get this from the calculator, but you can get this. Are we together? But the calculator will not bring it like this. The calculator will put theta in bracket like that. See there? So it means you must have 2 closing brackets. The bracket closing this theta and the bracket closing outside for cube. Are you seeing that important step? That is where everybody normally goes wrong. Because you end up closing one bracket, and the moment you close one bracket, it means you are cubing theta. So you are getting a wrong thing, isn't it? But you should not be cubing theta, you should be cubing sine theta. So for you to cube sine theta, you must have 2 closing brackets. See there? But the calculator will not put the bracket into different sizes. The calculator will have the bracket to be the same size, like that. Are you seeing? So it means you must have 2 closing brackets when you put cube. If you have one closing bracket, it means you are cubic theta and you are getting it wrong, isn't it? Are we together?
Yes.
Good. So you've written y in a form which can be evaluated using the calculator, as we'll see that, isn't it? Now after that, the next thing is to get the size of each and every interval. For you to get the size of each and every interval, you must know the number of intervals required, and that is from the question, isn't it? So the question you'll be told, use trapezoidal rule with how many strips? 8 strips. Strips are the parts. So you know each and every part has its own interval, isn't it? So if there are 8 strips, it means you have 8 intervals. We've not started talking about ordinates. Because ordinates, we are still not there. When we are in H, we are talking about intervals. It has nothing to do with ordinates, isn't it? Are we together?
Yes.
Meaning if you are given here to be 8 ordinates, is when you check how many ordinates, how many strips do I have in this ordinates. That means you have to check the rule, isn't it? So if you are told 8 ordinates and the rule is trapezoidal, the number of ordinates are higher than the number of strips by 1, isn't it? Are we together?
Yes.
Good. So 8 strips, number of strips is always equals to the number of intervals. Okay? So can we now get our edge? Meaning for you to get edge, you are told to start from 0 to pi. Meaning it is going to start from 0 and end at pi. Meaning the whole of this length from 0 to pi here, it is pi minus 0. The whole of that length is pi, isn't it? And you want to divide into how many equal intervals? Because each strip has 1 interval. So 8 strips means 8 intervals, isn't it? So you want to divide this pi into 8 equal parts, meaning each part h will be the whole length, which is pi, divided into 8 equal parts, isn't it? Are we together?
Yes.
The whole interval, which is pi, because pi minus 0 gives you the whole of that length to be pi, and you want to divide it into 8 equal parts, 8 equal intervals, isn't it? So each interval is going to be what? Our h is going to be pi over 8. So what is pi over 8 in the calculator? Because pi euro is 3.14 something. Pi over 8 is 0.3927, isn't it? After finding pi, we need to get x naught, where the first interval is going to start, isn't it? In trapezoidal rule, it is starting exactly at that first interval, at this 0, isn't it? It is only in mid-ordinate rule where it starts in the ordinate in the middle. See there?
Yes.
Only in mid-ordinate rule only, because in only mid-ordinate rule is where the ordinate is in the middle. The rest, it starts where the interval is starting 0, isn't it?
Yes.
Meaning automatically your x naught is what? Are you seeing that?
Yes.
Automatically your x naught is? It starts exactly at that point. It's only in mid-ordinate rule is where you are going to look at what is in the middle, isn't it? So x naught is automatically 0. So it means when you are dealing with the trapezoidal and the Simpson's rule, x naught is automatically that 0. It is the mid-ordinate rule which you are getting that value x naught to be in the middle. Tuko pamoja?
Yes.
So Simpson's and trapezoidal rule, x naught is automatically there. Is the concept understood? X naught is starting at that 0. Okay? So if x naught starts at 0, meaning the last x value will end at exactly pi, because trapezoidal rule and simple rule are not using ordinates in the ends, isn't it? Meaning both 0 and pi are going to be included. Are we together? So it means the moment you reach pi, you reach the end. And pi, you know the moment you reach 3.142 something, isn't it? You reach the end. And by then, you will know the number of ordinates. If there are 8 strips, you will see there are 9 ordinates if you count them, isn't it? So the point here is what? 8 strips in trapezoidal rule, how many ordinates are those?
7.
Who is saying 7?
9.
8 parts in trapezoidal rule.
9.
Number of ordinates are more. Because it is starting at the start and then one part has 2 ordinates at the end, isn't it? Meaning the middle ones are going to be sharing some ordinates. So number of ordinates are more. So 8 strips means 9 ordinates. Are we together?
Yes.
Are you getting the point where confusion is? With me, my work is to spell out where the confusion comes in. Because these things you can go and read them and do. But the moment you are reading them and doing them on your own, you are not seeing these gaps I'm trying to explain. Are you getting the idea? Those gaps are what I'm interested in. Okay? Good. Now from there, we now know 8 strips or 8 intervals will give me 9 ordinates. But if you are told 9 ordinates here, then you know you ought to have had 7 strips, isn't it? Are we together? Are you seeing the difference?
Yes.
Good. So, how many parts do I want to form my table here? How many ordinates I mean? Because parts are strips, 8 strips. How many ordinates do I need here? 9. So you form 9 ordinates. Divide it 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, which value are you adding? You are adding the h value, so you must write h on top here, isn't it? H is 0.3927. Then your x naught is what starts, isn't it? What is x naught?
0.
It is starting at 0. So we have x1, x2, x3, x4, x5, x6, x7, x8. So this is what you do. Press in the calculator 0 is equals to 0. Isn't it? 0 is equals to? So when 0 is equals to 0, it means that is your answer, isn't it? So it is now going to be answer plus h. Answer plus h. Answer plus h gives you x1. Are you seeing what we are doing? See, when you press 0 is what you are starting from. If you are starting from 0, you press 0 is equals to 0, meaning this 0 is now the answer. Press 0 is equals to 0. Then it is now answer plus h. So answer, if you add h, you get x1, isn't it? Are we together?
Yes.
Answer plus h, you get x1. So what are we found to be x1? 0.39? So if you press equal to again, it means it is now adding h automatically. Are you seeing that? It is now adding h automatically. Meaning if you press equal sign, you get x2 on the spot. Equal to 0.7854. If you press equals to, you get x3 on the spot. Because it is answer plus h. It is adding h automatically. Okay? Are we together? And what do you get to be x3? 1.1781. Then x4, if you press equals to 1.5? 708, isn't it? If you press equals to 1.9635. If you press equals to 2.3562. If you press equals to 2.7489. If you press equals to 1.6. So you can see the last ordinate is 3.416 and 3.114 is pi, and you can see pi was the last. Are you seeing? Are we together? Yes, because 3.142, approximately 3.142 is the pi. You've reached the last ordinate. And if you counter them, you will see there the 9 ordinates from 8 strips. Are we together? So from there, we now need the y's. x0, you get y0. x1, you get y1. x2, you get y2. x3, y3. x4, y4. x5, y5. x6, y6. x7, y7. x8, y8. You go to the formula of y. Go to your calculator, you press the formula, your y is 2 over, you shift the calculator to bring for you that root. Remember, that keyword is written x raised to power. Meaning when you shift it, you get for any root, isn't it? Not all the time it will be cube root, it will be any root. So if you shift it, then you put 3. When you shift it, it will bring for you this key like this, isn't it? When it brings that, you put 3 here for cube root. Are we together? Yes. So put 3 there for cube root. Once you put 3 here there, then you scroll. You have the 4 scroll buttons, those ones. So you scroll with that one forward to keep the value which is here. Isn't it? See, under there, this replace, it has 4 scroll buttons. So you press forward to put the value which is here. And that value which is there is what? So it is 5.
Yes.
You put 5, then it is plus. Then after 5, you have 4/3. This is how to put 4/3. You go and press the key for fraction. Once you press the key for fraction, you put 4 there, then you press the down scroll button and you key in the 3 there. See there? After you've done that, it will give you your 4/3. After getting 4/3, you press the forward scroll button to come in front of it, isn't it? And in front of it, what do you do? So you put the bracket first. If you don't put that bracket, you are getting it wrong when you are going to cube, isn't it? You must put this open bracket so that you are going to cube the sign. If you don't put this open bracket, it means you are cubing theta, and that is wrong. Are we together? So you put open bracket for sign. Then you put the value of theta, isn't it? And that value of theta, the first value of theta is x naught, meaning you come here and write this is theta naught, this is theta 1, this is theta 2, this is theta 3, this is theta 4, this is theta 5, this is theta 6, this is theta 7, that is theta 8, because theta is occupying the position of x, isn't it? So put in the value of the first theta naught, which is, but the calculator will open for you the bracket for sign, isn't it? When you put 0, you close the bracket. For that 0 is when you now close this outer bracket, meaning you must have 2 closing brackets, isn't it? Then you go and you press that symbol for x raised to power anything. Then it will tell you to put in that power, isn't it? So you press this key, it is telling you that any value raised to any power, isn't it? Then that power is what? The power is, you put that to power 3 there. So after doing all that, and remember you started by setting your calculator in pi radians, because these things are in pi radians, isn't it? When you press equal sign, what do you get? 1.1696. The calculator is in R. That's the same thing you are getting. Are you sure? Good. Is that what you are getting? 1 point? It's already there. So you're seeing it is blinking. So you press 3 here. Then you know you don't go back. You can go back and if you see an error, just press this replay button and you tell you where that error is and you correct. The next one, what have you found? See, the next one, you just press the backward replay button to go back where the 0 and you edit the value of 0 with this, isn't it? So there, when you edit the value of 0, what do you get? 1.1696. I edit the value of 0. Yes. You are back. Move back. Move back. Delete that one. What's supposed to be 1 point. That is 0.3927. You get 1.6. 1.1638. 1.1638. Remember, getting these values is what is important. So these are the points you need to master. That's why I'm putting a lot of emphasis on them, isn't it? And at the next value, edit the value of theta 2, edit. What do you get? Look at the way that guy is stranded and confused, because he doesn't have the right tool for doing this. You see? Very stranded and very confused, just like the other guy there too. The backbenchers. So here you have 1.156. So if you are not doing these things when we are doing them now, it means you are going to have problems in the future. 50.
Yes.
Then tell me the next one, edit the value of x3 of theta 3. 1.09. 7.5. Edit the value of x3, put the value of x4 here. What do you get? You just replay back and you change that value. 1.0810. Do that, continue doing that, continue editing that value.
Just move forward up to the end of that value. After you reach the end of that value, you relate to what you know is in there. Then you enter what you need.
1781.
After you found that, you press anything to show you where that error is. That error is there, meaning you. What have you done there? Why is even your side? Your side is not even there.
See,
you have a lot of problems which need
special attention.
you have a lot of
You are suffering, so
you close with the two brackets. So you think you are getting it.
1.0975. Continue. So you see, the moment you are making more practice, are you seeing it is getting easier to you? So practice is what makes perfect. So Y5, what have you found? If you edit this value of x5 here, if you put the value of x5 here, what do you get? 1.0. 1.0975. Y6, if you edit the value of x6 here, what do you get? 1.1? 350. If you edit the value of x7 here, what do you have? 1.1? 638. Then here, if you edit 1.1696. 1.1696. Is everyone getting those values?
Yes.
Yes, it is just a matter of replaying back and editing the value for x or theta which is there, isn't it? After you've done that, you now write the formula for the trapezoidal. Are we together? For the trapezoidal rule, you come and list your ordinates here. You don't even need to list. You know the area according to trapezoidal rule is given by a half h, isn't it? A half h, then sum of the ends. The ends are what? See, y naught and y. Which ones are ending? See, the one which is starting is y naught, the one which is ending is y8. Yes. So it is now y naught plus y8, isn't it? Then it is plus twice what is remaining, isn't it? Yes. Are we together? Yes. The ends, the two ends are y naught and y8. You add them, then twice the medulus, isn't it? And which ones are the medulus? From y1 to y1 plus y2 plus y3 plus y4 plus y5 plus y6 plus y7. Those are the medulus, isn't it? Yes. So you don't need to substitute these values here. You go to the calculator direct, okay? Then you put a half times h, a half times 0.3927. That is not the work of calculator, okay? Go to the calculator. And remember, because this bracket is not in the calculator, so look at what is there. Look here. Bracket, bracket. So this is what you are doing. It is a half times h, which is 0.3927. How many brackets are opening? Meaning if you put one opening bracket, you get the whole of it wrong. Meaning you'll be getting half h of this only, isn't it? Are you now seeing what I'm explaining? Yes. Meaning here you must have the bigger bracket for the outer and the bracket for this inner. That's why clever people normally does have this, then he adds this and put the value here to avoid that confusion, isn't it? So h naught plus h8, what do you get? So that you avoid that confusion, you work out what is in this bracket first, if you cannot use those double brackets. And what is h naught plus h8? Remember, it is a half h of everything inside the bracket. So start by getting this part. Start by getting this part. H naught plus h ends, the sum of the ends. This plus this. What do you get? 2.3? 2.3392. Then it is plus 2 into the sum of all these. So 2 into y1 plus y2 plus y3 plus y4 plus y5 plus y6 plus y7. Because y naught and y8 you've already added here, isn't it? So 2 into all this, what does the calculator gives you? To into all that, continue adding. So, yeah, so twice the whole of that, you get 15 point. 15 point. 72. So in the end, a half of times this, what do you get outside here? A half times 0.3927, then in bracket this plus this. So I have a half times 0.3927, then what do you get to be this plus this inside the bracket? Work out inside the bracket first. This plus this, 2.3392 plus 15.7472, you get 18.0864. So can you now get me the final answer? A half times 0.3927 times 18, because you now have a single value inside the bracket, isn't it? Are we together? You must work out the bracket to be a single value if you want to avoid those double brackets, okay? A half times 0.3927 times 18.0864, what do we have? Half times 0.3927 into 18.0864. What do we get with the answers? 3.5? 3.5513. That is the approximate area. What did you get to be the area in ordinate rule? It was also 3.5513. Yes. Because we were using few decimal places. But if there were many decimal places, you would have seen some smaller difference, isn't it? Because these are approximated values, isn't it? If we would have been to 6 decimal places, there would have been some slight difference in the approximated areas with the different rules, isn't it? Very good. So that is how to deal with the trapezoidal rule. So we want to use this same rule. We want to use this same example for the Simpson's rule.